Welcome to Grade 12 Advanced Mathematics, Unit 5, Integration, Topic 5.3 Area. Let's explore the concept together. In this video, we will learn how to estimate the area under a curve on a given interval using rectangles. Welcome to HasnaSparkVibes. Let's spark our math skills together. Now let's begin. First of all, let's focus on the important formulae to remember. What is length of each subinterval? Exactly. Delta x is equal to b minus a over n. How will you find out your a and b? It's nothing but from the closed interval. Your first number is known as a and the second number is known as your b. What is n? N is nothing but the number of rectangles. Now how will you find the points? xi is equal to a plus I delta x. And what about I? I ranges from 1, 2, etc. up to n. Now let's find the area. How? Yes, using sigma notation. Sigma I equal to 1 to n f of xi delta x. On our first example, approximate the area under the curve y equal to f of x equal to 2x minus 2x square on the closed interval 0, 1. Here I used Rn as 10. That means using 10 rectangles. Suppose you are looking only for the final answer or you are facing multiple choice questions, you can directly enter by using the integral symbol. The lower interval is 0, which is your a, and your upper interval is 1, which is your b. Enter the function 2x minus 2x square. Don't forget to use proper bracket when you enter in the calculator dx. You will get your final answer directly. Here let's focus on our steps. What's your first step? Perfect. Find delta x. b minus a over n. Already we noted our n is 10. Also our a is 0 and b is 1. So we get our delta x as 1 over 10. Now let's look at the points. xi equal to a plus I delta x. Already we know a is 0. So let's remove a. So we are left with I over 10. And I ranges from 1 to etc. up to 10. Why 10? Because n is equal to 10. Now let's find area using sigma notation. We know our n, we know our f of x, we know our delta x. Let's substitute. But don't forget to replace our xi by I over 10. Which means all your x in the function will get replaced by I over 10. Since 1 over 10 is a constant, you can take it outside so that it will be reflecting in your calculator as 0.33. Let's try with the same function but this time using 20 rectangles. So your n will be turned as 20. I request you all to pause the video and try this question. Don't forget to comment your answer. Let's continue. Here your delta x formula remains the same as b minus a by n, but as n is 20, it will change to 1 over 20. which is 0.05, and your xi becomes 0.05i, where I ranges from 1 to 20. And what about your area using sigma notation? When you enter in the calculator with your replaced xi, which is 0.05i, if you notice here, replace all your x with now 0.05i. You will be receiving it as 0.3325. The area under the curve for the function on the interval 0, 1, we are supposed to check it for large values of n, say 10, 20, that we already tried just now, then 50, 100, 500, 1000, like that. At a point, you will realize all those numbers are approaching to your final answer, which you got it from the calculator. Yes, exactly, 1 over 3. Hope you understand the question. Please do try it out, and if you have any queries, don't forget to comment below. The previous question, what did we do? We applied with the large values of n, right? So we are going to connect it with our definition 3.1. Limit n approaching to infinity, sigma equal to 1 to n f of xi delta x is nothing but our area. So hereafter, you can use the formula limit n approaching to infinity, sigma equal to 1 to n f of xi delta x to find the area. The second example. It's the same function as in the first example, same interval, but this time n is not given. So we will maintain it as n itself. So what about your delta x? B minus a over n. What is your a? Your first number, and your b is the second number. So when you substitute, you will get your delta x as 1 over n. When you look at your xi, it is nothing but a plus I delta x. What it is? I over n. And your n, we don't know, so we'll replace it as 1, 2, 3, etc. up to n. Let's find the area. Limit n approach to infinity, sigma equal to 1 to n f of xi delta x. But first, let us focus on finding the sigma. We will replace our xi with I over n and our delta x with 1 over n. In your function, let's replace our x with I over n. And when you simplify, you will multiply your n and n. So you will get n square, and the second term you will be getting n power 3 because you have n and n square. Let us take the common term outside. 2 over n square and 2 over n power 3 is taken outside. Here we need to remember the formula, sum of the first n natural numbers. What it is? Exactly, n into n plus 1 over 2. And what about the formula of sum of the squares of the first n natural numbers? Very good. N into n plus 1, 2n plus 1 over 6. So once you substitute those two formulas, after that you can simplify. Here what did I do? I cancelled 1n in the numerator and 1n in the denominator. Over the second half also I cancelled n in the numerator and 1n in the denominator. Also I cancelled this 2 and this 2. Also this 2 with 6, so that the denominator become 3. So you are left with n plus 1 over n minus n plus 1 times 2n plus 1 over 3n square. Further simplification results in n square minus 1 over 3n square. How? The LCD. So when you look at here 3n square, here you have n. So we need to make both the terms as 3n square. So what is missing? 3n is missing. So multiply it on both numerator and denominator in the first term. Second term, no need to do anything because already you have the common denominator 3n square. After that, using distributive property, multiply with the first term and the second term, you will get 3n square plus 3n. Here I use the FOIL method and you get 2n square plus 3n plus 1. Since the denominator is same, let us club it. What is 3n square minus 2n square? N square. 3n and 3n will get cancelled because you have a minus sign here. Then you are left with plus 1, but already you have a minus sign, so minus plus is minus. That's how you got n square minus 1 over 3n square. Now it's our turn to multiply our n with large numbers. At that time, what you will notice? When you round it off, you will be approaching to infinity and your final answer will be 1 over 3. You can even understand the horizontal asymptote concept. If your denominator and the numerator's degree is same, you can divide the leading coefficient. That's the most easiest technique to follow this. So the answer is 1 over 3. Let's try this question. Please pause the video, try it yourself and comment your answer. Let's identify our A and B. What is your A? A is 1 and B is 3. N we will maintain it as N. At the last we will be applying some large value. So let's find delta x using the formula B minus A over N. So what is delta x? 2 over N. And what about xi? Exactly 1 plus 2i over N. Let's substitute in the sigma formula first. So your xi will be replaced by 1 plus I times 2 over n and your delta x with 2 over n. If you notice your f of xi root x plus 1. So your x, don't forget to replace it by 1 plus 2i by n. Already you have a plus 1. Don't forget it. Okay dear girls? So let's proceed. Don't forget to use a proper bracket. So you will be left with 2 plus 2i by n under the root and the constant 2 by n is taken outside sigma. Let's apply any value for n. It should be a large number. Here let us try it out with 500 and you got the value as 3.44886685. Let's try with some large values like 1000, 5000, etc. When you try it out, you got the values like this and all these values get approximated to 3.44783 and we will round our answer as 3.4 or depend on the decimal places they ask in your question. That's all for today. Catch you in the next concept. Until then, keep watching and keep practicing math. Remember, practice makes perfect. Thank you and bye-bye.